So we're going to continue looking at equilibrium, and we're going to look at it in terms of Le Chatelier's principle. And Le Chatelier's principle says that when stress is applied to a system at equilibrium, the equilibrium will shift in the direction needed to relieve that stress. All right. So if I apply stress to a system, the equilibrium is going to shift in order to relieve that stress. So you can think of it in terms of balance. We are going to shift in order to balance out. So let's look at how concentration would affect the equilibrium. All right, so in terms of concentration, if I increase concentration, I am going to see a shift to the opposite side in order to use up what was added. A decrease in concentration is going to shift to the same side in order to replace what was moved. All right, let's look at temperature. In terms of temperature, an endothermic reaction, if it is an endothermic reaction, if I add heat, I'm going to shift right. If I remove heat, I am going to shift left. If it is an exothermic reaction, when I add heat, I shift left, or the reaction shifts left. Remove heat will shift the reaction right. In terms of pressure, if I decrease volume, then I have an increase in pressure. So a decrease in volume increases the pressure, and I am going to shift towards the side with the least number of moles. If I increase volume, that is going to decrease pressure. Now remember, guys, pressure is going to be collisions. So if I decrease volume, then we have the same amount of substance in that container, but the container is smaller. So we are going to therefore increase the number of collisions and increase pressure. If I increase the volume, that same amount of substance now has more space. So we are going to decrease the overall number of collisions and therefore the pressure as well. And a quick review, this is the relationship between volume and pressure is Boyle's law. So a review from our gases unit. All right, so if I decrease the pressure, I am going to shift towards the side with the most number of moles. And so right now, all we're doing is we're getting some definitions, and then we're going to make sense of it. What happens when I add a catalyst? Here's that word again, catalyst. Okay. If we add a catalyst, it has no effect. All right. So adding a catalyst is not going to stress the system. So let's look at an equation. And let's see if we can't make sense of all of these rules that we just wrote down. My suggestion to you guys, instead of memorizing these rules, think about it logically. All right, so instead of memorizing the rules that we just wrote down, it is really and sincerely a logical thought process. So what's going to happen if I add NO2? What's going to happen if I remove NO2? What's going to happen if I remove heat? And what's going to happen if I decrease the volume? Okay. So here's my equation. 2NO2 gas yields N2 gas plus 2O2 gas and 22 kilojoules. Kilojoules is how we measure heat. Heat is measured in kilojoules. So this is the heat. So this is an exothermic reaction. Exothermic reactions produce heat. If I produce something, that heat is in the product side. If heat had been a reactant, then it would have been an endothermic reaction. All right, but since heat is a product, this is an exothermic reaction. Exothermic reactions produce heat. So let's come back up here and let's just do a quick exothermic and let's say produce heat. So heat is a product. And an endothermic reaction, endothermic means it uses heat, it absorbs heat. So heat is going to be a reactant. So let's go back now to our equation and let's think about this and walk through these logically. If I add NO2, I add a reactant. That means I now have more reactant than I had. So I am going to shift right in order to use up this reactant. So I'm going to shift right, and what that means is I am going to make products in response. So if I add reactant, I need to get rid of what I added. The only way to get rid of what I added is to make products. Shift right. If I remove NO2, so I take it out, I need to replace what I removed. The only way to replace it is to make it. So this is going to be a shift left. These products will make NO2 to replace what I removed. Shift left. If I remove heat, heat is a product. I take it out. So if I take out heat, I have to replace it. That is a shift right. In terms of equilibrium, I am going to make products in order to produce heat because I need to get that heat back that I take out. So if I take out heat, I have to get it back. Shift right. Decrease volume. When I decrease volume, I am compacting, making it smaller, the container smaller. So I am going to have more collisions. So I need to have less collisions. I have more because I've shifted it and increased the pressure. So how am I going to get rid of the pressure that I have now created? All right, this is where the number of moles of gas come in. I have 2 total moles of gas on the left side. I have 2 plus 1, 3 moles of gas on the right side. So 2 total moles of gas as reactants and 3 total moles of gas as products. So if I increase pressure, I am going to shift left towards the side with less moles, because less moles of gas will have less collisions, and that is the overall goal, to get back or as close to where I was before I stressed the system. Okay, so I increase pressure, more collisions. I need to get rid of those collisions that I have created, so I'm going to go to the side that has less moles of gas, less collisions. So I think about this in terms of a logical thought process. And when I was first sitting in your shoes, I tried to memorize these rules, and I found equilibrium to be really tough until later on when I realized, wait a minute, I can just think about this in terms of a logical thought, right? If I add something, I got to take it away. So how do I take it away? By using it up to make products. Okay, so if you think about it in these terms, I think you'll find equilibrium to be not so overwhelming. So instead of trying to memorize these rules, just think about, well, I need to go back to where I was. How am I going to get back to where I was?